Welcome back, students. This is the Q&A session 32 from the playlist of NEET Physics Part 1, and the topic for this session is law conservation of linear momentum. So here I have taken this question which was asked in the CBSE All India Pre-Medical Test in 2008, and this question is based on the law of conservation of linear momentum. So here the question is, a shell of 200 grams is fired from a gun of mass 4 kg which generates 1.05 kilojoules of energy. So the initial velocity of the shell is, there are 4 options here, so we have to find the correct one. So now let us consider that the velocity of the shell after firing is in this direction as indicated by this arrow. So this is the direction of velocity of the shell is as given by this arrow, and let us say this is V1. So when the shell is fired from the gun will recoil in the opposite direction. Gun recoil. So the direction of velocity of gun recoil will be opposite to the direction of velocity of the shell after firing. So I am just considering the velocity of gun recoil as V2. Okay, now I will be using the law of conservation of linear momentum. That is, the total linear momentum should be the total linear momentum before the firing should be equal to the total linear momentum after the firing. So the total linear momentum of this shell and this gun is 0 because the velocity is 0. The velocity of the shell and the gun is 0 before the firing. After the firing, the velocity of the shell is V1 and the velocity of the gun recoil, which is in the opposite direction of the velocity of the shell, is V2. And this is V1 velocity of shell after firing. This is equal to V1 meter per second. And the velocity of shell, velocity of gun recoil, I have taken it as V2 meter per second. So the total linear momentum before the firing should be equal to the total linear momentum after the firing. So the total linear momentum before the firing would be 0 because the velocity of shell and this gun gun recoil is 0. After the firing, the velocity of the shell is V1. So the momentum associated with the shell will be equal to 200 grams दिया हुआ है यहाँ पे. So I will be converting it into kg. So this will be equal to 2000 divided by 1000 kg into V1. So this is the momentum associated with the shell. And since the velocity of the shell is in the opposite direction of the velocity of the gun recoil, therefore here I will be here this velocity V2 will be taken as negative. So the momentum associated with this this gun after the firing will be equal to mass into V2. And here minus sign means that the velocity of this gun recoil is in the opposite direction of the velocity of the shell. So from this equation, I am getting that 4V2 is equal to V1 upon 5, or we can say that the velocity of the gun recoil will be equal to V1 upon 20 meter per second. Now the total energy generated due to this firing is equal to 1.05 kilojoules. So I will be getting another equation, that is half mv square. The kinetic energy associated with this shell will be equal to half mv square. Vm is the mass, so this will be equal to 200. I will be converting into kg. Half m v1 square plus half mass of the gun, which is equal to 4 kg, and V2 square. In place of V2 I will be putting V1 by 20 because we have to find the velocity of the this initial velocity of the shell. So this will be equal to v1 square divided by 220 whole square. This is equal to 400, and this will be equal to 1.05 kilojoules. So I will be converting it into joules. So this will be equal to 1.05 into 1000. So this will be equal to 1050 joules. Now from here this will get cancelled out, and this 2 and 2 will get cancelled out. So I will be getting v1 square upon 10 plus from here this will get cancelled out. So I am getting 2 here, and so from here I am getting v1 square divided by 200. This is equal to 1050. Now I will take the LCM. This will be equal to now v1 square can be taken as common from can be taken as common. So I will be getting as I have taken the LCM now, and here I will be getting as 20 plus 1 is equal to 1050. So it implies that v1 square is equal to 1050 into 200 divided by 20 plus 1, which is equal to 21. So 21 into 5 will be equal to 105. So if I will I will just divide this. So this will equal to 50. So 50 into 20, and this is equal to 10, 1, 2, 3. So v1 square is equal to 10,000, or we can say that v1 is equal to under root of 10,000, and this is equal to 100 meter per second. The under root of 10,000 will be equal to 100. So the velocity of the shell is equal to 100 meter per second, and the correct option is A, that is this one, 100 meter per second. So in this question the most important thing was to apply the law of conservation of linear momentum, and using that this law I was able to find the velocity of this gun recoil in terms of the velocity of the shell, and thereafter I have substituted this value while in the second equation in which the total kinetic and the total energy generated due to this firing was equal to 1050 joules. So thank you very much for joining this session. I hope you have understood the solution of this question. So in the next session, that is in the session number 33, I will be coming up with the another question from the chapter of work, power and energy. So till then, have a nice day. Bye.